Now comes the fun stuff of direction angles. So if u is your unit vector, such that theta is an angle from the positive x-axis, that means if it's in standard form, then the terminal point of u lies on your unit circle. What we're going to have is some unit vector. So we have a unit vector, u is equal to x comma y, equals, now instead of having an x, we're going to have a cosine theta and a sine of theta for y. Remember, way back in like chapter 4, when we first learned about if you have an ordered pair on your circle and you have an x comma y, well, didn't we also say that meant that if you had an x, isn't that your cosine of theta, and isn't your y your sine of theta? That is if you are on your unit circle, because that means you would have your x over your y, or sorry, your x over your radius, and your radius is a 1. So cosine of theta is your x. In order to write this as a linear combination, then we can talk about writing it as the cosine of theta I plus the sine of theta j. So your angle theta is called your direction angle of your vector. So if any vector v or u or z or whatever, ai plus bj is any vector that makes an angle theta with the positive x-axis, then what you can do is you can write v as taking your magnitude of v times your cosine of theta, and then your magnitude of v times your sine of theta. So you're basically distributing. This is where v is a scalar multiplication. So we're going to have a v cosine theta I plus a v sine theta of j. So let's look at our first example here with example 7. Look, Easter's canceled. Oh, that's mean. I know. I'm sorry. I shouldn't have said that. I'm sure there's some bunny lovers out there somewhere. Sorry. Okay, just kidding. All right, so what we need to do is we need to find our direction angle here for A. So in order to find your direction angle first, notice this is the same thing as having a negative 6 comma 6. That means if you were on a coordinate plane, then if you went back 6 and up 6, you would be at this point. And you would have this nice pretty little triangle in quadrant 2. Because if your first value is negative, doesn't that mean you go to the left, negative 6? And if your second value is a positive 6, doesn't that mean you go up 6? So what you get is you need to find out what your theta is. Now your theta will be this angle with your positive x-axis all the way over to here. In order to figure out what this theta is, well, we do what we've done before. You're going to take you're going to look at your opposite value and your adjacent value. That is your tangent. So we're going to find, if we set this up as the tangent of theta is equal to y over x, then in order to figure out what theta is, we need to take the arc tangent of both sides. So that means we're going to find the arc tangent of y over x. So if we plug in our y and our x, we're going to say theta is equal to the arc tangent of 6 over negative 6, which is really the arc tangent of negative 1, which is going to give us theta is equal to 135 degrees. So make sure your calculator is in degrees once again. You're going to plug in the arc tangent of negative 1. That should give you a 135 degrees. Now let's look at B. B, we have the ordered pair of negative 7, negative 4. So what quadrant would we be in? You're right. We would be in quadrant 4. So we're going to draw a triangle in quadrant 4.
Leonard, if you're in the building, please report to the...
Haha, I so lied. It's not in quadrant 4, it's going to be in quadrant 3. So let's draw this in quadrant 3. Nice straight line here, Klein. So let's go back 7. down 4. And we're going to find our theta, which is going to go all around here. So in order to figure out our theta, we're just going to do the arctangent of your y over your x. So we're going to get the arctangent of -7 over -4. Scratch that. I wrote that wrong. Once again, it's a good thing I find my mistakes, not you guys, because then somebody might be making fun of me. Your y is -4, your x is a -7. So if we plug this into our calculator, you're going to go to your calculator and you're going to type in the second tangent of -4 divided by -7. And when we do this, we get the answer of, now wait a minute, that's not in quadrant 3. Oh, so what you're saying is maybe the tangent, maybe your calculator took the arctangent of a +4 over a +7. Because if you take a negative divided by negative, isn't that a positive value? Yes. So your calculator actually found this angle over here. Whoops. Let's do that a different color here. Actually found your angle in quadrant 1. So it found this to be, this angle is a 29.7 degrees. Well, that is basically a reference angle. So that means that this angle from here to here is 29.7. And what you're going to have to do is you're going to have to add, since you're in the third quadrant, are in quadrant 3, you need to add 180 plus your 29.7 degrees. So that is going to give you a 209.7 degrees. That is your theta. That is your theta.